Algebra 2. This is a review of how to simplify square roots from Algebra 1. So in the unit you're going to study, you need to know how to simplify square roots. So let's go through just a review of how to do that. Remember, when we're simplifying, we are actually just taking any perfect squares that we can, or any perfect squares of any factors that we can. We're not putting the roots on our calculator and estimating. So the first thing that will help you is just to review the perfect squares from 1 to 100. So these are numbers that have an integer square root, and it's not 2. So we have 1 and 4, because 2 squared is 4, 9, 16, 25, 36, 49, and you probably see the pattern of how I'm getting these, because I'm squaring 8, and then 9, and then 10. So these numbers are perfect squares. They have even square roots. So we'll be on the lookout for those numbers. So to simplify, the first thing you want to do is find the largest perfect square that divides into the number that you're trying to simplify to take the square root of. Then you rewrite that square root as those two multiplied together, and then take any square roots that you can. So on number 1, the square root of 9, that is a perfect square, so that is 3. We're only going to give the primary or the positive square root because out front we just have a implied positive sign, not a negative sign, so it doesn't want the negative square root, it just wants the positive. Now on number 2, the square root of 12, 12 is not a perfect square. So we're going to break it into factors where one of them does have a perfect square. So I know that 4 times 3 is 12. And so I can break that into the square root of 4 times the square root of 3. Then I'm going to take the square root of 4, which is 2, and then multiply times the square root of 3. And so this is our final answer of that square root of 12 simplified. On number 3, we have the square root of 18. Notice I have the perfect squares written down below. 18 is not a perfect square. I can think of factor pairs, 2 and 9, and I realize that 9 is a perfect square. So I'm going to rewrite it as the square root of 2 times the square root of 9. Then I can't evenly take the square root of 2, so that's going to stay underneath that operator, that radical. But I can take the square root of 9, which is 3. I'm going to write that in front because if I put it at the end, I might get confused about if it's supposed to be underneath or not. So this is our final answer simplified. Now with 20, if we think of factors of 20, I've got 2 and 10, but neither of those are perfect squares. 4 and 5, and I can see that 4 is a perfect square, so I'm going to rewrite it as that product. I'm going to take the square root of 4, which is 2, and then keep the square root of 5. Now number 5, we've got the square root of 24. 24 is not a perfect square, so I think of factors. 2 and 12, neither of those are perfect squares. 4 and 6. 4 is, so I'm going to rewrite that as the square root of 4 times the square root of 6. Then I can take the square root of 4. And so simplified, I have 2 times the square root of 6. Now look at number 6. We've got the square root of 28. And so I can break that into factors. So I think of my factors, 2 and 14, I'm actually going to write them down this time. Neither of those are perfect squares, so 4 and 7. Those are perfect squares, so I can rewrite that as the square root of 4 times the square root of 7. I'm going to take the square root of 4, which is 2. And then I can't evenly take the square root of 7, so I will leave that. Alright, factors of 40, so I have 2 and 20. Neither of those are perfect squares, 3, 4, and 10. 4 is a perfect square, so I'm going to rewrite that as the square root of 4 times the square root of 10. I'm going to take the square root of 4, which is 2, so I end up with 2 times the square root of 10. All right, let's do a little more practice. So 75, square root of 75. 75 is not a perfect square if you look at our perfect square list, but think about factors of it. So we can do 5 and 15, but neither of those are perfect squares. So past 15, 25. 25 and 3. So I can rewrite that as the square root of 25 times the square root of 3. Square root of 25 is 5. And I can't take the square root of 3 evenly, so I leave it. All right, 80, 2 and 40. Neither of those are perfect squares. So 3 and 4, 4 and 20. 4 is a perfect square, but I'm going to keep going. So 5, if you divide 80 by 5, you will actually get 16. And so 16 is a bigger perfect square than 4. So I'm going to break it into that pair. So square root of 5 times the square root of 16. I'm going to take the square root of 16, which is 4, and I'm left with 4 times the square root of 5. All right, lastly, square root of 82. So if I divide that by 2, I get 2 and 41. And then there are no other factors, and neither of those are perfect squares. So sometimes our square root is already in simplest form. One other thing that I want to say is that a radical, and in particular the square root that we're working with, it's an operator in math. It tells us to do something. Just like this addition sign is an operator, this subtraction sign is an operator, and this division sign is an operator. So notice, if we go ahead and do these operations, so 3 plus 2, of course that's 5. See when I do the operation how the sign goes away. I don't need that sign anymore. 4 minus 2 is 2. So notice my subtraction sign goes away once I subtract. 15 divided by 3 is 5. And then finally the last one, the square root of 9 is 3. So again, notice that my operator, it goes away once we do the operation. So when you take a square root, you no longer need that symbol.